Okay, hey guys. So what I'm going to do now is walk you through this handout that we did in class. So let me actually find my share screen, share, and then I'm going to flip over here. Okay, so we talked about the importance of surface area to volume ratio, and the amount of surface area is to volume ratio is a really important concept to understand. And so I kind of wanted to do this little activity to help you guys understand what are the factors that control surface area to volume ratio. And the ones that we're going to look at is size. And then we're also going to look at shape. So let's look at this assignment together real quick. So, well, the first thing that we need to do is be able to calculate both the surface area of a cube and the volume of a cube. And then later on, and the second part of the assignment, we'll find the surface area and the volume of a cylinder. So let's focus on the cubes first. So the first thing that we're going to do is compare the surface area to volume ratio of a large cube to a small cube. So you can answer this question. Which one do you think is going to have a larger surface area volume ratio, the big one or the little one? You can write that in and justify your answer. So to just remember what we're doing as far as the math goes, to get the surface area of a cube, we need to find the length of this side. So this is length times width. And that gives us the surface area of one of these faces, but we need to find the surface area of all of the faces. So I created this down here for us to be able to use this really easily. So the large cube, for this one, it is 10.9 centimeters along one side. And so if I get on my math machine and if I say 10.9 times 10.9, that gives me the surface area of one of these faces. Okay, so I'm going to write that. I'm going to record that here so that I don't forget. 8.1. Okay, and now in order to get the total surface area of the entire cube, I need to multiply this number by 6 because I have 6 faces on this cube. Okay, so I'm just going to do that in my math machine right here. And then that gives me a number that is 712.86. Okay, so now that's the surface area. So that's half of my equation. Now I need to find out the volume of that. And in order to do that, I just need to multiply the length times the width times the height. And so that's just 10.9, which is the length, times 10.9 times the height times 10.9 times the other one that I didn't say. Length times width times height. Because this is a cube, they're all the same length, so we can just cube it. And that gives us 1,295. Okay, so now we have the information to get the number that we actually want. Okay, we want the surface area to volume ratio. So here's our surface area. So we just punch into our math machine, 712.86 divided by our volume. That's 12.95. Okay, and that gives me a number that's 0.55. And that tells me how much surface area there is for the amount of the entire space that's taken up by this cube. Okay, so we're going to do that same thing again, but we're going to do it with the little cube this time. So the little cube has a length. One of these side lengths is 3.7 centimeters. And so in order to get the surface area of one of these faces, I need to go 3.7 times 3.7. That gives me a number that's 13.69. Then I need to multiply. So that's the surface area of this face. I need to know the surface area of all the faces all together. So I'm going to multiply that by 6 because that's how many faces there are in a cube. That's 82.14. Okay, now, so that's my surface area. I'm done with that part. Oop. Now I got to find the volume. Length times width times height. Okay, 3.7 times 3.7 times 3.7. Okay, that gives me a number that's 50.653. Now I can calculate the number that I actually care about, which is the surface area. So that's 82.14 divided by the volume, which is 50.653. That gives me a number of 1.62. Oopsies. Okay, so now I can compare these two, and I see that the amount of surface area compared to the volume that this small cube takes up is much bigger than the surface area. Even though this has a bigger surface area, much bigger surface area, the surface area to volume ratio of the little guy is much bigger. And that's why we see cells that are small. When we did the food coloring experiment, one of the facts, so we did temperature, we factored in molecular weight, and we looked at solute density. But one of the things that we did not factor that we didn't test that affects how fast things diffuse is distance. So if you think of a solute at the very center of this cube, it has to travel quite a much farther distance than a solute in the middle of this small cube. Okay, so that tells us that this tiny little cube is going to have a greater surface area to volume ratio. Things are going to diffuse in and out of a smaller body faster than a larger body. Okay, so that's the point of that. Now what we're going to do is compare shapes. How does the surface area to volume ratio change when we're comparing shape? Okay, so you can answer those questions there. Okay, so now we're going to pretend that this little whiteboard marker is a perfect right cylinder. So even though this kind of does pinch in a little bit and there's this little bump here at the top, we're going to pretend that it's a perfectly right cylinder. Okay. So in order to do that, we need to get the surface area of our whiteboard marker, and then we need to get the volume of our whiteboard marker. And I've included the formulas for those things, but that's pretty complicated. But so what we can do is we can just open up a Google tab and we can, let's go the surface area of a cylinder. Let's just Google that. And now all we need to do is enter the radius and the height. And so I've already measured these. So our height is 12 centimeters. And the radius, so what we'll need to remember is that the radius is half of the diameter. And so these markers, it is 0.8 is the radius. And so that tells us that the surface area, oops, not 0.8, 0.8. Okay, that tells us that the surface area is 64.34. So now I'm just going to copy that information. Oops, I don't know what I just did. And I'm going to put that in my thing here. So my height was 12, my diameter was 0.9. My diameter is 0.19. Actually, I can't remember what the diameter is, but I do remember that this is 0.8. So our surface area, what did I say it was? 64.43. Okay, so now we're going to Google, instead of the surface area, we're going to look at the volume of a cylinder. Oh, I don't want videos. I just want this. Okay, so now I got my little online calculator, so I can type my numbers in again. What did I say? 0.8 and the height was 12. And so now our volume is 24.13. So let me click back here, 24.13. And now I can get my surface area to volume ratio simply by taking this number, 64.43, divided by the volume, which is 24.13. And that gives me a number that is 2.67. And so what we're going to do, so how does the surface area of the whiteboard marker compared to the surface area of the small cube? So the surface area of the whiteboard marker is 64 and change cubic or square centimeters. And then this one is 82 and some change. And so what we're really seeing is that they're kind of similar, but what we see is the ratio of the cube is 1.62, but the ratio for our marker is much larger. It's 2.67. So really the roundness of this also gives it a higher surface area for volume ratio. So they're very similar in their surface area, but their surface area to volume ratio is much different. Okay. So that is that. So hopefully that makes sense for you guys. Hopefully that concept of why surface area to volume ratio is so important, it makes a lot more sense now. And so if let's just kind of digest this a little bit. So the distance between a solute has to move from the center of this to the exterior is very small, much smaller distance compared to this. So that's why we tend to see cells that are either a cylinder in shape or a sphere, is to maximize that surface area to volume ratio, because that's how things diffuse in and out. Cells are more efficient with higher surface area to volume ratios. So hopefully that makes sense. Let me know if you have any questions on that.